Today we are going to talk about Section 11, or Section 4 of Chapter 11, Area of Regular Polygons. I'm showing you the page of notes, which I'm going to upload to Edsby prior to this assignment so that you can take a look at it. You take a regular polygon, you pull out a triangle inside for reference, and you do all your work pretty much from that reference triangle. And the reason for that is you're using a formula which talks about the radius, which goes from the center to the corner of a polygon, and the apothem, which goes from the center to the side of the polygon. So you pull the tiny triangle out, you find that apothem, and you find that radius, and you move on to use trigonometry. So these problems are going to take everything that we've talked about and use that in order to solve. All right, these are my two example problems. First thing I need to do is see what information I'm given. I have 10 inches here for a side of the regular polygon. Now that means all these sides are all equal to 10. However, my sketch is a little wonky looking, but they all should be equal to 10. What I need to do is find this degree measure. Well, first I ask myself how many of these little triangles exist in this figure, and that would be, there would be 2 triangles attached to every side. So there are 5 sides. 5 times 2 is 10. So to find that degree measure, I have to take 360 divided by 10, and that gives me 36 degrees for that angle right there. Then I have to use trigonometry. I need to find this side, which is the apothem, and that little cursive A stands for apothem. So I think I'm going to circle this point here and here, which should be opposite and adjacent, and that's going to be tan. Tan 36 degrees is equal to this portion of the triangle. That's just from here to here, and if this is the midpoint, this edge is 5. So the opposite is 5 over the adjacent, which is the apothem. That little funky A stands for apothem. So now we're just doing a trigonometry problem. Tan 36 degrees, I'm going to put a 1 under that, is equal to 5 over the apothem. Cross multiply. Tan of 36 degrees times the apothem is equal to 5. So if I want the apothem by itself, I would have to take 5 and divide by tan 36 degrees. And when you put that in your calculator, you're going to get approximately 6.88. And that is your apothem measurement. Now, once I have the apothem and I can calculate the perimeter, I can use the formula for this unit, or for this section of the unit, which is area of the regular polygon is equal to 1/2 times the apothem times the perimeter. Well, for this problem, that would be 1/2 times the apothem length we just found, 6.88, times the perimeter. Now, of a polygon, there are 5 sides times 10 on each side. So the final answer for that would be 1/2 times the 6.88 times 5 times 10. It's 172 inches squared. Okay? All right, that's our first example. And our second example is a different shape. This one is 1, 2, 3, 4, 5, 6. 6 sides, that's a hexagon. Take a look at my small triangle here. How many of these tiny triangles are inside this hexagon? Well, this 360 degrees would have to be divided by 6 times 2, because there are 6 individual sides and each side would be faced with 2 triangles. So that's 360 divided by 12. So that means that the degree measure I'm looking for in this figure is 30. That's 30 degrees here. Now, if you know your 30, 60, 90 formulas, you're home free on this problem. I'm just going to pull out this little triangle right here so we can see it more closely. If that's 5 square root 3 and this is 30 degrees, what is this side? Remember, this side is the short leg times square root 3. So this is 5. Making this 10. Correct? What is this side? This is 5. This is 5 square root 3. Remember, the hypotenuse would have to be double the short leg. So that is also 10. Really cuts our work short in this problem. Now, do we have all the information needed to calculate the full area? If area is equal to 1/2 times the apothem times the perimeter. I certainly can calculate the perimeter because that's going to be this 10 times 6 sides. And the apothem, they already gave us 5 square root 3. So that's 1/2 times 5 square root 3 times the perimeter, which is 6 sides, and each of them are 10. That means our final answer, 259.8 centimeters squared. All right. I may have a video up later by the end of this week or the first of next week for finding composite figures, because that's the last part of this particular unit. Thanks. If you have questions, let me know on Edsby, and please watch the video multiple times if it's beneficial. Thank you. Bye.